I help new members of Notion's support team really comprehend the most advanced features of Notion. They explore my resources in Notion A to Z, and then we convene for a series of live lessons. And through this series, How Notion Learns Notion, I'm making those lessons available to you. And those of you who have joined Notion A to Z will have access to all the interactive features, including the working demos and the practical exercises. And if you haven't yet joined Notion A to Z, I encourage you to join us so that you can master and make the most of Notion.
Earlier this week, we dove into kind of an introduction to formulas, which is going to continue to be our focus. Today, we're going to dive into some common functions within each of those function categories that we introduced earlier this week. So, just as we did last week, I'm going to have you set up a little sandbox page where you can do some mini practices as we learn each concept. And you can go ahead and create a new page. And just as we did last time, you can choose the table layout for that page. That's going to convert it to a database. You can call it your sandbox, as in Williams Sandbox. And then name each of those three default items: item A, item B, item C. And just for good measure, we'll sort by that title property, by the name property, because it's always a best practice to sort every database and every database view in Notion. You can go ahead and convert that default multi-select property to a formula property that we'll use to practice some of these functions. So with that in place, just a reminder that you'll have access to this page after the session. You can duplicate it to review all of its contents. And most importantly, you'll have access to those functional demo databases that'll allow you to dissect them and see exactly how they're configured. So let's briefly recap those fundamentals of functions. So remember, functions are kind of like packaged actions that you can perform on the input values that you supply your formulas. Remember, when we're working with formulas, we have two kind of types of ingredients primarily. We have the inputs, and then we have the actions that we want to perform on those inputs. So functions are a way of specifying the actions that we want to perform on those input values. And each function begins with a keyword that typically represents its operation, such as add, which we saw last time, or multiply. And then that keyword is followed by parentheses. And within those parentheses, that's where you supply your function its input values on which to perform its operation. Or in the case of functions, those input values are known as arguments. And so most functions are going to require a specific quantity of arguments or specific data types for its arguments. And that kind of gets back to, we talked about the importance of data types when working with formulas. So, for example, you can't supply text strings to the multiply function because multiply is only going to return the product of numbers. So each function is going to have particular requirements for the data types that it accepts, and in most cases for the quantity of arguments that it accepts as well. So just briefly recapping those data types, remember every value within a Notion database, whether it's a formula property or any other type of property, it's going to be one of four data types. So we have text strings, we have numbers, we have dates, and then we have Boolean values, which are either true or false. So, as you're working with formulas, you can reference a few different resources for different function types, what their requirements are, and what they do. And within the formula window, when you're editing a formula, remember over on the left side of that window, you have a list of optional ingredients to include, and that list includes all of the functions that Notion makes available. And when you hover over one of those functions, on the right side of the formula window, you're going to get some helpful information. You'll get a description of the formula. You'll get a list of the arguments that it accepts. So that'll be under the syntax section. You'll see the types of input values that it accepts as well as the number of them. And when there is no limit on the quantity, as we saw last time, you'll just see an ellipsis rather than just a defined number of inputs separated by commas. But there are some limitations to the information available within that formula window. So I have this Notion formula cheat sheet, which I believe we also took a look at last time, which is linked from this page for today's workshop. And that's going to provide a bit more information about each formula. It also includes the various operators, which we looked at last time, and some more intuitive descriptions and examples. So I'm told that this is often referenced by the Notion team. I think you'll find it helpful as well. So let's look at a quick demo of a function before we dive into some of those common ones. And for today's demonstrations, we're going to be working a lot with a sample database of students. And each student is going to have 3 exam scores. These are just simple number properties. So for each student, we have score 1, score 2, and score 3. And we're going to be using formulas and specifically functions to work with those exam scores. So if we look at this formula property here, we've added all of the scores together to determine a total score. But more usefully, we use another formula property here to find the average score. So what the average score does is it uses the divide function, which begins with the divide keyword, and it divides the total score by 3 because we're working with 3 different scores. So we have a reference to the total score property as the first argument of the divide function. And then the second argument of the divide function is going to be the number by which we want to divide that first argument. So we just enter the literal value of 3. So in this case, this property reference, the value that it represents is going to be different for each student because each student has different total score. But this literal 3 is going to be the same for each execution of the formula because we're entering it literally. We want to use 3 for each iteration. So let's give it a quick practice in your sandbox, this time using the multiply function. So within that formula property, just type the keyword multiply and give it any 2 numeric arguments. And we'll just enter them literally. We won't use any property references. So we can just type multiply and then open up our parenthesis. And I'm just going to give it a 2 and a 3 separated by a comma and submit. And so we get a 6, which is the product of 2 and 3 for each iteration of the formula because we used literal values. So that's a recap of functions. Let's dive into some common examples. And if you'll recall, I kind of categorize functions in 4 ways, typically corresponding with the types of inputs they accept or the types of inputs that they return. And on that note, just a quick reminder that each formula returns a single value. So no matter how complex the formula, it's always going to return a single value, and that value that it returns is going to be one of these 4 data types. So you don't only want to consider data types for your input values, but also for the value returned by the formula, because that's going to impact the calculations that you can perform with that value and where you can use it in other formulas and so forth. So we've been working a lot with number functions already. We've seen add, we've seen multiply, and we've seen divide. Let's look at 3 more common ones that you'll find helpful and that you'll probably encounter in your work with Notion users. So remember, for our students database here, we've got 3 different scores, and we use the addition operator to calculate their total because remember, add only accepts 2 arguments. So In that case, if we're working with 3 different values, we just use that addition operator, the plus sign, to add them together. We didn't look at that particularly here, but that's how we would do it. But we did see how to determine their average by dividing their total score by 3. And so what we can do is you may want to know the lowest score for each student. And in that case, we can use the min function that's gonna return the lowest of its arguments, the smallest of its arguments. So you can see here that we use the min keyword to start the min function, and over here, we can see that this ends with an ellipsis. So we know that we can supply more than 2 arguments. So what we've done is for the arguments of min, we've made 3 property references. We supply it with score 1, score 2, and score 3. And so for each student, we get the lowest score. So let's give that a quick try within your Sandbox. Type that min keyword and just give it any 3 numbers, and you'll see that it returns the lowest of those 3 numbers. Of course, the return value is the exact same for each item of the database because we're entering literal values. We're not making property references. So as you might expect, Max does just the opposite. Instead of returning the lowest score from the students, it returns the highest of those 3 scores. So what we can do is instead of using the min keyword, we use the max keyword for the max function, and we still supply those 3 input values, those property references, just as we did last time. But instead of returning the lowest score, it's going to give us the highest score from each student. So let's give that a quick practice. If you still have your min example in place, you can just change that min to a max, and you'll see that instead of returning the lowest of your 3 inputs, it returns the highest. So round is another useful one. What round does is it just rounds to the nearest integer, as you might expect. So when we saw that average score, look how nasty this average score is with all these decimals. Very rarely are you going to want to be viewing that as your final output. So what we can do is after calculating this average score with that divide function, we can use another formula property to round that average to the nearest integer, which gives us a much nicer returned value. So let's practice round real quick. Then that formula property, just type round and give it a number with a lot of decimals. You can just go wild with the number keys on your keyboard, and you'll see that it rounds to the nearest integer. Now, just a quick note, we won't look at these, but there's also the ceil function, which is always going to round up, and then the floor function will always round down. But round will add to the nearest integer, up or down. So those are some additional number functions. Let's look at some more text functions. And so text functions, obviously, they're generally going to manipulate text strings that you provided as its arguments. And you don't need to do anything differently when you're referencing other properties for your text strings. But if you're providing them literally, you'll surround them with quotation marks. Quotation marks surround text strings. So we've seen the concat function. Concat concatenates text values or merges them. Concatenates is just another word for merging text values. So we can see here that if we wanted to generate a summary for each student, we could combine their name, the status property here, which we'll look at later, and then their score. So you can see here that we can use that using the concat function, where we just use our concat keyword, and then in parentheses, we provide the inputs that we want to merge together. So in this case, that's a combination of property references and literal inputs. You can see why in some cases you'd provide property references, And in other cases, you provide literal inputs. For example, our colon and space is the same for each item of the database. So we just provide that literally, but the name and the status and the score, they're all unique to each student. So they're property references. So let's practice concat here. We'll type that concat keyword and then just provide it with your full name. But as the second value, as the second argument, let's give it a space. In my case, it would be William, comma, space, and comma, nut. So I can submit and I get my full name where the first name and last name is separated by a space. Now, join is another common text-based function. It works similarly to concat, but the first value that you supply the join function is going to be the character or the text string that separates each of the additional values. So if you were assembling a list, for example, you could use a comma space as that first input, and then each of the additional arguments are gonna be separated by that comma space. You don't have to include the comma space multiple times. Or in the case of your name, that first argument could be the space that you wanna use to separate your first name and last name, and then the second 2 arguments could be your first name and last name with no spaces. So here's an example of that list example. If we take our 3 exam scores, we can list them separated by a comma and a space using join. So with join here, the first argument is comma space, and then the following arguments are going to be references to those other score properties. Now, I've used format here for reasons that we'll explore a little bit later, but basically all you really need to see here is that the first argument is a comma space, and then it's followed by references to each of those exam scores. So each exam score is separated by that comma space. We don't have to supply that comma space multiple times. So let's practice that real quick. If you still have your concat function in place in your formula property, you can just change it to join, and then you can remove that second argument. And let's make the first argument a comma space, and that's going to insert that comma space between the William and nut. But in the case of a name, we don't need the comma, do we? We just want the space. So we can remove it and submit. So those are a couple of common text-based functions. Now, let's move on to common date functions. So dates are a little bit more nuanced. You can't supply dates literally, like you can just enter a number or enter a text string. There's only 3 ways that you can provide dates as the inputs for your formulas. So the most common way that you'll provide a date is by referencing a date property. But there's also the now function, which is one of the few functions that accept no arguments. And all the now function does is each time you load the database, it's going to return the current time. And that's going to be helpful, you'll see, for calculating time since a past date or until a future date. And then we also have the from timestamp function, which you'll use infrequently, if ever. I touched on that last time. And from timestamp, it accepts an integer, and that integer represents the number of milliseconds since Unix epoch time, which is midnight, January 1st, 1970. There are reasons actually why that is helpful. But like I said, you use that pretty infrequently, and we're not going to spend a lot of time with it here. For the most part, we'll be working with dates that are supplied by referencing other properties or by using the now function. So, as I mentioned, now accepts no arguments. You can just enter now with an open and close parenthesis. And each time the database loads, it's going to return the current time. So you can see if I enter now as the only ingredient of this formula, then we get the date and time in my time zone. So try that on your own in your sandbox in that formula property. You can just enter now, open and close parenthesis, and you'll see it for yourself. So now let's look at a couple a few of common date functions. The date between, as I mentioned, a lot of times you'll use Notion formulas to find the amount of time since a past date or until a future date. And to do that, you'll use the date between function. And the date between function accepts three arguments. The first one is typically going to be the later date. The second argument is going to be the earlier date. And then the third argument is going to be the unit in which you want the return value. A lot of times, really, in most instances, you'll be finding the amount of time between either a past date or a future date and now. So you can consider in our students database, say we have an enrollment date for each student when they enrolled in the past, obviously. And if we want to calculate how long they have been enrolled, particularly in months, we can use date between. So we start our formula with the date between keyword. And remember, the first argument is typically going to be the later date. So if we're finding the amount of time between a past enrollment date and now, the now is going to be the later of those two dates. So now is our first argument. And then we want to know the amount of time between the enrollment date and now. So we use the enrollment date as the second argument, and we want that returned in months. So the third argument is going to be the unit that we want the return value to be in, and it's going to be all lowercase, it's going to be plural, and it's going to be a text string. So we surround it in quotation marks. So when we submit our formula, we get the amount of time since that enrollment date in months, the number of months since that enrollment date. So let's practice that quickly. To do that, let's add a date property to your sandbox. And in this case, let's give each of your sample items any future date. And then in your formula property, we're going to use date between. And instead of making that first argument now, because that future date in your date property is going to be the later of the two dates, it's going to be our first argument. So we'll type date between, and then the first argument is going to be a reference to that new date property that you just created. The second argument will be now, because it's the earlier of our two dates. And let's use days this time. So in quotation marks, type days, plural, all lowercase. And then we'll close out our date between function, submit. And I've got past dates here, so we've got a negative result. So I'm going to quickly change my dates here to future dates, and that's going to give us positive return values for each formula. So dateAdd is another common date-centric function. dateAdd allows you to add time to any date. So the first argument is going to be the starting date, the date to which you want to add time. The second argument is the quantity you want to add, and then the third argument is the unit for that quantity. So if we want to add 5 days, then the second argument will be 5, and days will be the third argument, formatted in the same way that we formatted our unit for date between. So let's say that for each student, if they enrolled at a certain date, they would need to renew 1 year later. So to determine their renewal date, we would add 1 year to enrollment. So to do that, we would use dateAdd, and we're starting with enrollment date. So we make a reference to that enrollment date property, and we're adding 1 year. So the second argument is just going to be 1. And then even though it's just 1, our unit is always going to be specified in the plural form, all lowercase. So we provide years as a text string. So when we do that for each student here, we get 1 year later than their enrollment date. So let's practice that quickly. You've already got a date property in your sandbox. So let's just, within that formula property, type dateAdd, and let's make a reference to that date property. And then maybe we want to add 1 week. So let's type 1, and then the last argument will be weeks. Close it out. And for each item, we get 1 week later than that date. So dateSubtract works the exact same way, but instead of adding that amount that you specify in the second argument, it subtracts it from that starting date. So formatDate is another really helpful date-oriented function. Notion is really pretty limited in the options that it provides for you to format your dates, but with the formatDate function, you can format a date in virtually any way. So if you want to display it in one of these summaries that we're creating, or as you'll see in the gallery view of a database, then you can use the formatDate function to format it however you want. So formatDate is going to accept just 2 arguments. The first argument is the date value that you wanna reformat. Typically, it's going to be a reference to a date property. And then the second argument is gonna be a text string that's a pattern from the moment.js format. And I've linked to cheat sheet for moment.js. It's pretty straightforward. You're just combining capital and lowercase M's and Y's and D's and so forth for representing months, days, and years. And then you can get as specific as minutes and seconds and so forth. But you'll want to take a look at this cheat sheet for Moment.js because it breaks down all of the different elements that you can use to kind of construct the format that you want. But we'll just look here at this example with years, months, and days. So we have our enrollment date, and let's say we just wanted simply to reformat our enrollment date using this year dash month dash day format where it uses leading zeros if a month or a day is only 1 digit. That's going to give us a consistent number of characters for each date, and it's going to format them where the date is first. So if we wanted to sort by text alphabetically, for example, if we were using any sort of tool that may be limited to alphabetical sorting, this would allow us to sort still chronologically. And in some cases, it looks a little nicer. So you can see here that we've got our format date keyword, and then the first argument is a reference to the enrollment date. And then the second argument is our moment.js text string pattern. So what that is, 4 capital Y's representing the year, dash 2 capital M's representing the month as digits with a leading zero as necessary, dash 2 capital D's, which works the same way as months, but for the days. So you can tinker with this a lot to get a feel for how Moment.js works. And like I said, you're going to want to reference that cheat sheet. But let's do a quick practice here. So we already have our date property in the sandbox. And let's this time format our date with, I like to format 2 digits for each month, day, and year with leading zeros as necessary, separated by a period. So what we do, format date, reference our date property as the first argument. Then the second argument is going to be month, 2 capital M's, period, day, 2 capital D's, period, year. This time we're just using a 2-digit year. So we can close out that text string, submit, and we get our reformatted date for each item of our sample database. So those are some of the most common functions that you'll encounter and work with within each kind of function category. Let's take a look at a couple of kind of challenges that come with working with data types, and we'll take an even closer look at some of these data type challenges in some later lessons. As I mentioned, inevitably, you're going to encounter a type mismatch error when working with functions and formulas, and that's when you are using incompatible input values for functions or when working with operators. You can't add a text string to a number, and you can't concatenate or merge a text string to a date. So, as a quick another example here, remember we created our summary for each student. And when we did that, we used a combination of property references and literal values. But if we had just supplied this max score value within this text string, we would have gotten a type mismatch error because we'd be trying to concatenate or merge this text string and this text string and some of our literal text strings with a number. We can't use a number within a concatenation. Otherwise, we get a type mismatch error. So if I remove this format here, you can see here that we get a type mismatch. If we just reference the max score within this concat function, we get a type mismatch. You can see down here that we get type mismatch. Max score is not a text. And we'll take a look here in a second at that format function that we use to convert it. Now, a couple of other notes about working with data types. Remember, a text property is always going to represent a text string. So if you reference a text property, it's always going to be a text string, even if its characters are all numbers, even if it contains what appears to be a numeric value. So within a text string, if you type 1, 2, 3, 4, 5, it's a text string. And when you try to use it in a formula, it's only going to work as a text string. Then a number, of course, is always going to be a number. And what you can see here is these are aligned differently. So a quick way to remind yourself of the data type of a value in a database is to look at its alignment. So you can see that this 1, 2, 3, 4, 5 is aligned to the left, indicating that it's a text string, whereas this input value is aligned to the right, indicating that it's a number. And when a formula returns a value, it's going to uphold that alignment. So if we reference that 1, 2, 3, 4, 5 text property, then the resulting value for the formula is going to be aligned to the left. But if we represent the number version of it, now the returned value is aligned to the right. So when a formula returns a value, it's always one of our 4 data types, and it's going to uphold that sort of alignment principle. And as we've talked about a lot, a formula can return any of our 4 data types. So it's really important to keep in mind not only the data types of your inputs, but also the return values of your formulas. So let's look at an example here of why that's going to be important and why this formatDate property is helpful. So within our students database, we have an upcoming birthday property, basically their birthday, but for the next year. And if we were to just display that value within this gallery view, this upcoming birthday, we don't necessarily know what that date represents. The gallery view doesn't offer the option to display the name of the property along with its value. So in a lot of cases, it's helpful to concatenate that value with a label. In this case, we might want to say birthday and then include this date. But if we were to concatenate the word birthday with that date, then we're going to get a type mismatch because we're trying to concatenate this text string with a date value. And I'll just demonstrate that. You can see upcoming birthday is not a text. But when we reformat that birthday with that nice period format, it's also going to convert it to a text string. So if we instead reference the formatted version of the birthday, it's going to accept it. So within our gallery view, instead of displaying the birthday property, what we can do is display the labeled birthday. And you can see now we have that nice period format for each birthday, and we have the text string birthday to indicate what it actually represents. So we've concatenated the word birthday with the reformatted birthday. So you can get a sense for why these various text-based functions can be helpful. So let's look at 2 functions that allow you to change the data type of a value. The format function is going to accept any value of any data type and convert it to a text string. And so that's going to be useful for creating kind of these summaries or these labels within galleries, because if you have various text strings and you want to merge it with an exam score or a birthday or so forth, you need that exam score to be a text string. You need that birthday to be a text string. So you can simultaneously reformat the birthday and convert it to a text string using the formatDate function, or you can use the format function. So with the format function, It just accepts that one argument, any value, and it returns that value as a text string so that you can use it within these concatenation formulas or other text-based functions. So let's give that a quick practice in your sandbox. You have that date property already. So let's type the keyword format and then let's reference that date property and then close out the format function and submit. And we get what appears to be the exact same value as the date property, but its data type is a text string now. It's not a date. So we can concatenate this value with other text strings, whereas we're going to get a type mismatch error if we try to concatenate this date value with other text strings. And then toNumber kind of does just the opposite. What toNumber does is it takes any value and converts it to a number. So in the case of a text string, it's going to try to interpret its digits as a number. True is going to be 1, false is going to be 0. And then if you supply a date to the toNumber function, it's going to convert it to that Unix time that we talked about, the number of milliseconds since 1970. So let's practice toNumber real quick. We don't have a text property in your Sandbox database. Let's add a text property real quick, and let's just type some numeric digits within each cell of that text property. And notice that they're aligned to the left, indicating that they are indeed text. And then over in the formula property, let's convert each instance of that text property to a number. So we'll type the toNumber keyword. We'll make a reference to the text property. And you can see that we get the exact same values, but in this case, they're aligned to the right. So what that means is we can use them in mathematical formulas. You can also format them in those different numeric formats and perform calculations on them, whereas none of those options are available for the text string versions of these values. So you'll really get a sense of the challenges of data types and how to work with them as you practice. In that spirit, I have another practical exercise for you. And this one, what you'll do is you're going to create a database, and it's going to be in all of these demo databases. We were working with a list of students. In this case, we're going to create a database of golfers. So I've walked you through some kind of directives for this golfers database. And then after you add all of these properties to that golfers database, some of which are date and number properties and so forth, and others are formulas that reference those values, I'm going to have you create a gallery view that does basically what we did previously, as we saw with those students and representing their birthday with a label. And if you get stumped anywhere or you want to validate your output, then I have the final outcome down here too.